This UCSD TV program is a presentation of University of California Television for educational and non-commercial use only.
We all strive to live a long, prosperous, and healthy life. With advances in health and medical sciences, this goal is ever more attainable. The Sam and Rose Stein Institute for Research on Aging is a nonprofit organized research unit under the auspices of the University of California at San Diego, committed to advancing lifelong health and independence through research, education, and patient care. To better empower and improve the lives of young and old alike, the Stein Institute presents the following program.
Welcome. I'm here to talk to you guys tonight about social networks. And most of the time when I tell people that I study social networks, the very first thing that comes into their mind is, oh, you must know everything there's to know about Facebook. Well, actually, I got into this research not because of Facebook. I started doing this research over 10 years ago, way before Facebook was born, because I was interested in a different kind of social network. I was interested in a social network that looks like this. We have always had friends. We've always had family members. And one of the things that makes human beings unique as a species is that we maintain long-term, non-reproductive relationships with people that we're not related to. That's a really fancy way of saying we have friends. And in order to be able to really understand what's going on online today with our hundreds of friends that we have so-called online, I think it's really important first to step back and try to understand, why is it that we have friends in real life? Why is it that we maintain these relationships in these groups? And how has that contributed to us spreading good behaviors and spreading what it means to be human throughout these social networks? Well, first of all, before we talk about what a network is, we have to figure out what the basic building parts of a network are. And that's going to mean that we need to think about what it means to actually be a friend. And so let me ask you this question, and I want you to answer it for yourself. What do you think a friend is? Well, one way that you can think about what a friend is, you can think about who your friends are. But of course, as a researcher, I don't want you guys all thinking about different things, because we have different criteria that we use to establish who's a friend and who's not a friend. And so to get you guys all on the same page, I want to ask you two questions that we normally ask whenever we are trying to ascertain who's friends with whom in any kind of a population. So the first of these questions is, who do you discuss important matters with? I want each of you to answer this question for yourself. Make a mental list. Close your eyes and think about, who do I discuss important matters with? Just take just a moment. Okay, so I told you we're going to have two questions. That was one. Another question that we ask is, who do you spend your free time with? And so think about that one for just a moment. You don't always discuss important matters with the people that you spend free time with, and vice versa. But these are two ways of getting at the kinds of people that we have these long-term relationships with that we think are going to be really important for a wide variety of human behaviors. And so I want you, throughout the course of this talk, I want you to think about your list. I'm going to be showing you some abstract representations of social networks, but at the end of the day, each one of the lines on these maps is a relationship. And what do I mean by that? I mean something that looks like this, where you have two people that have some kind of a relationship. We can represent that as two circles and the line between them. A social network is really nothing more than a set of people and the relationships between them. And so this is the most fundamental building block, is these specific relationships that you have with each of the people on your list. But you probably will already observe the fact that even if we were just to restrict our social network study to you, it probably wouldn't look like this, because you probably named more than one person on your list. In fact, when we ask people throughout the United States with Gallup to name their friends in the same way that I'm asking you to name your friends, we get an average of about 5 people that are named. So people have about 5 of these friends on average. And these friends aren't necessarily just friends. They can include spouses, it can include coworkers, it can include neighbors, It can include fellow students if you're in college. And it can also include people that we just think of as friends rather than one of those other categories. And so what we need to do is we need to start thinking about, well, what are the consequences of it being not just you and one other person? What if it's many pairs of individuals that we have to keep track of? Well, one of the things that starts to happen when you start thinking about many pairs is that not only is it the case that you're going to have an influence on somebody that you're talking to or you have a relationship with, but there are going to be other people in the room that are doing the same thing at the same time. And the reason why that's important is because at some point, if you add up enough of these friendships, you're going to start to see that they're interconnected. And this has huge, huge implications. Because what this means is that you not only are having an impact on the people that you're talking to, that you're having a relationship with, that you're discussing important matters with, if you actually change what they do, then that changes the way that they behave with other people as well. In other words, we have an influence not just on people that we can see, we also have an influence on people that we can't see. And so think for just a moment of the people on your list. How well would you do if you were going to make the list for each one of those people? In other words, do you know who all your friends' friends are? Probably not. You may know some of them, but as you get more and more distant in the network, to friends' friends, to friends of friends of friends, it probably becomes harder and harder and harder to know who those people are. And these are people that many of whom you don't know and have never met, even though they might be quite important to people that you have a direct connection with. And for that reason, I think it's really important that we understand these social networks, that we understand the full set of relationships in these populations, because we cannot go on continuing to think that we are like Robinson Crusoe on our islands. We have an impact on people we can see, and this potentially can spread throughout the network. Now, if I sound like an acolyte, the reason why is because about 10 years ago, when I started studying social networks, I had this pivotal moment where I realized something about social networks. And like all good academic inspiration, the thing that inspired me was a commercial from the 1970s. And this commercial from the 1970s was about this woman who loved her shampoo so much that she shared it with two friends. And the screen split into two, and you saw two women who both were just loving their shampoo. And then the announcer says, and she told two friends, and the screen splits into four, and so on, and so on, and so on. And pretty soon there are 64 women that are enthralled with this shampoo because of one person's actions, because of one person's decision about the shampoo that she would use. And what I realized when I was thinking about that commercial was that even though each one of us may have only a small impact, small direct impact on the people that we can see, say I'm only going to increase the chance that you do something by 10%, well, if I do that for everyone on my list, and it changes even one of those people, then there's a domino effect, because now that person has the potential to change everyone on their list. And it's this power of exponential numbers that potentially can make the actions of a single person turn into something that's much larger than we really understand from seeing our own interaction with the world. Now, this is kind of a crazy idea. I went to my advisor in graduate school and I said, you know, I want to study voting. I want to study how voting spreads in social networks, because I think that when I vote, I not only affect the people around me, which we already had some research to suggest that that was true, but that this spreads from person to person to person. And I got really excited and I told my advisor about the shampoo girl. And he looked at me a little funny, but then he remembered, wait a minute, there's a person that's just come to Harvard from Chicago named Nicholas Christakis. And he sounds just as crazy as you, because he wants to know how health effects spread through the network. He's actually an end-of-life care doctor. He worked in hospice for a number of years. And he's one of the world's experts on this effect called the widower effect. And this widower effect is one in which when one member of a spousal couple dies, it actually makes the other person more likely to die as well. And our best guess in the United States is that when the man dies, the woman loses about 2 years of her life, and when the woman dies, the man loses about 7 years of his life. Well, I'll let you speculate on the reasons for the differences, but the important point here is that the health effects are really strong between spouses. And so he was very interested in how spouses affected one another, and one day he got a call from what he thought was one of his patients. And this patient said, "Doc, you've got to help me. I'm having a hard time dealing with this person dying. Can you please prescribe me some medication? And Nicholas said, look, I'm happy to do that, but I have to apologize to you. I can't remember who you are. I have a really good relationship with all my patients and their spouses. Can you just remind me who you are? And the person on the other end of the line said, oh, don't worry, doc. I'm not one of your dying patients. I'm not one of your dying patients' spouses. I'm the friend of one of your dying patients' spouses. And it was for that moment that it clicked for him that this huge health effect that he was studying between spouses doesn't stop at the household door. That this can travel in social networks, that potentially this travels between friends, between neighbors, between coworkers, between all the people that we have relationships with in social networks. And so my advisor, in true social network fashion, introduced the two of us, and a relationship between Nicholas and I got started. And one of the very first things that we realized that we needed was data. One of the reasons why we haven't adequately studied this question in the past is it's very hard to figure out what these social networks look like. Okay, so just for example, I'm talking to you guys here tonight. You all gave me your list. Chances are there aren't a lot of intersections between those people. So your John is not the same as his John, and as a consequence, I'm not going to get a full picture of the network. I'd have to go and talk to all those people and to all of their friends and all their friends and so on to be able to get a map like this of the full social network. And so we started to think, well, how can we do this? We're going to need to have some study that's been around for a long time that already has a lot of good health and social data. And what we'll do is we'll just go and at the next opportunity to talk to the subjects of that study, we'll just start asking them to name their lists for us so that we can start to draw this social network. And so we turned to the Framingham Heart Study. This is a study that actually has been around for a very long time. It got started in 1948 with about 5,000 people, which at the time was most of this small town of, most of the adults in the small town of Framingham, which is a small town outside of Boston. This has now become a bedroom community, so it's become more affluent over the last 50 years. But at the time, it was really just sort of normal every town USA. And they started following them in 1948 and started following their children in the early 1970s and started following their grandchildren in the early 2000s. And so we thought, this is great. It's a small set of people that probably are very interconnected, which means that the probability that the person on one person's list is themselves a member of the study. And so because they're already well connected, this would be a good place for us to start asking these questions of the people in this study. And when we started talking to the people who run this study about it, they said to us, that sounds like a really great idea. Let us tell you a little bit about the study. We're actually very successful at keeping people coming back year after year. In fact, over 30 years for this offspring cohort that started in the 1970s, they've only lost 10 people to follow-up out of 5,000. And we said, how in the world did you do that? That's amazing. How is it possible that you could do this? And this administrator very blithely says, oh, that's easy. And she pulls out this thing called the green sheet. And the green sheet is a contact list where they ask you, the typical questions that they ask you when you go into the doctor, name an emergency contact. Well, you put down your spouse or your neighbor or something. But they went into much more detail than that. They asked people where they worked. They got addresses on everybody so we could map neighbors. They got all the family members extended. And most importantly, they asked people to name a close friend. And they had been doing this at every exam for the last 30 years. And I still get goosebumps when I tell this story because for us it was that moment when the mold fell in the Petri dish. We weren't going to need to go out and start from scratch. They had already been doing our social network study for us since the early 1970s. Not for the purpose of research, but just for the purpose of having this amazing retention rate for their study. And so the very first thing we did is we just got a grant and turned all of that paper data into electronic data so we could start looking at the network. Just to give you an idea of where these people live today, this is a map of Massachusetts. And that dark blue center, that's Framingham. That's the township of Framingham. Boston is in the middle of the sea over on the right. So it's sort of the dark green part on the coast. And you can see that the colors here indicate the darker the color, the more participants live in that part of Massachusetts. And one of the things you can see is they don't all live in Framingham anymore. They've actually spread out. And so you have some people who have spread out to the Cape. And actually, here in California, we have about 100 members of the Framingham Heart Study, as people have moved away and intermarried and so on. And so these folks are spread out all over the place. And this is going to give us an interesting opportunity to compare a traditional way of thinking about social networks with this newer way of thinking about social networks. So what is the traditional way? traditional way is what I would do is I would find out where you lived, and to see whether or not you were affected by people in your network, I would just go and take some average of all the people who live near you, so like some census block. And so say I wanted to know whether or not other people's socioeconomic status has an impact on your health, I would just compare the income of your neighborhood to your own health outcomes. Now that works really, really well if all the people on your list live next door. But think about your list. How many of those people live 10 miles away, or 100 miles away, or in some cases 1,000 miles away? As it turns out, in the Framingham Heart Study, we can demonstrate this quite clearly. What we do here is this is the township of Framingham, the same map as before, but now we've put a line between all the siblings. And you can see that there's a dense set of connections in Framingham, but many of them go out of Framingham all across the country. In fact, about 1/6 of the participants have friends who live more than 500 miles away. And this is actually a map of the friendships. The last one was the map of the siblings. So we needed a new way to map these relationships that wasn't based on geographic space, but it was based on social space. It was based on this idea that we want to put people close together in this map who have a social relationship, because we think those social relationships are going to be the ones that mediate the spread of behavior. And so the very first study that we did to draw these maps was a study on obesity. And in this study, what we do is we draw a map. This is about 1,000 people in the study. If I showed you all 5,000 people, it would look like a big ball of spaghetti. So we make the maps a little bit simpler just to demonstrate what we're looking at. And here, each circle is a person. Each line is a relationship. In this case, we've illustrated friendships, so non-genetic relationships, and also family members. And we color the nodes according to whether or not they are obese. So yellow nodes here are obese. Red nodes are normal weight, and we actually even make the nodes proportional to body mass index. So nodes of larger size are literally representing larger people. And one of the very first things that we saw when we drew this map was that there were clusters, and these clusters were actually quite extensive. And what do I mean by that? What I mean is I can actually predict your obesity outcome if I have information about the people that you're connected to. So if I don't know anything about you, but I know that you're a member of the Framingham Heart Study, and I know that you have a friend who's obese, then I can tell you that it increases the likelihood that you're obese by about 40%. If your friend's friend is obese, it increases the likelihood that you're obese by about 20%. And if your friend's friend's friend is obese, it increases the likelihood that you're obese by about 10%. So up to 3 degrees of separation, we found significant associations between two people's body mass index. Beyond 3 degrees of separation, we found no relationship. Now, the interesting thing about this is that it's consistent with the idea that our behaviors are spreading through the network. But that's not the only reason why we might find such clusters. Okay, so one possibility is that we're influencing other individuals. So I eat more, and as a consequence, my friends eat more. We already know from experimental studies, you set someone next to someone who's eating more, and we unconsciously will start to eat more. Or my friend starts an exercise regime and says to me, "Oh, James, I feel really good. I've just started jogging every day." And I think to myself, "Oh, I should really do that. I should really go to the gym more often." And so you can have positive and negative behaviors that can spread through the network that have an implication for this outcome of obesity. But you may also have these other processes that cause this clustering. And so, for example, one of these processes is called homophily. This is one of my favorite words. It's a word that literally means love of like. It's the idea that birds of a feather flock together. That bird didn't make the other bird look that way. That bird decided to fly next to that bird because they were a similar type. And so one possibility is that people of normal weight, for example, preferentially make friends with other people of normal weight. Or people who like to go to the gym tend to make friends with other people who like to go to the gym. So this is a very difficult problem to try and tease out which of these things is actually driving the association. Another thing that can actually be causing this clustering, though, is differences in the environment. And we can call this a contextual effect. And so the idea is that if a gym opens up in your neighborhood and you and your friend both join the gym and start going there independently, it doesn't have to have anything to do with your relationship. The fact that you're both exposed to this gym means your weight's going to go down together, even though it had nothing to do with why you became friends in the first place and had nothing to do with one of you influencing the other. And so one of the things we have to do in these observational studies is we have to figure out ways to tease apart all these effects. And one of the ways that we're able to do this with this particular data is to use overtime information. Because what we can do is not just see if there's an association, but see if there's a pattern where you become obese, and then your friend becomes obese, and then her friend becomes obese. And so I'm going to actually move this map in motion over the course of the 32 years of the study. And one of the things that you're going to see is that this changes like an amoeba. This is a superorganism of human relationships, like a set of cells that are connected to one another. And each one of these lines is a relationship. A new line might form and two nodes might come close together as people become friends or get married. They might fly apart when people get divorced, and you lose not only your spouse, but your spouse's friends. And one of the things that was really obvious in this movie when we first made it is the nodes over time were getting more yellow, and they were getting larger and larger and larger, consistent with what was going on in the rest of the United States. We are in the middle of an obesity epidemic, and one of the reasons why we were interested in doing this study is to think about whether or not we are literally in an epidemic, in the sense that the factors that underlie obesity can spread from person to person to person like a virus. So using this overtime information, we were actually able to try and tease apart how much of this association is actually due to influence. And one of the things that we were able to do is not only use overtime information, but we were able to use network information. And the way we were able to do this is, it's sad but true, some of the people on these individuals' lists didn't name them back as a friend. And so you might think about your own list. Which of the people on your list is the most likely that if you ask them, they wouldn't name you back? Now, I know that's a very sad thing to think about, but from the point of view of a researcher, it's actually a really useful thing to have those asymmetric relationships, because if it's the case, you think of someone as a friend, and they don't think of you as a friend, then what we would expect is that influence spreads from that person to you and not the other way around. And in fact, that's exactly what we found in this study. We found that if someone that you name as a friend becomes obese, then over the course of the next 2 years, it increases the likelihood that you'll be obese by about 57%. If you reverse the arrow and look at what happens to the person who's named as a friend, whenever the namer becomes obese, nothing happens. In fact, we're not able to show that that's different from zero. Also, whenever you name a person and they name you back, that's a sign of a stronger relationship between the two of you. It actually triples your risk of obesity when that person becomes obese. And so we found these social network effects by utilizing both time and this directionality in the social network that's consistent with a causal hypothesis. It's still an observational study, so let me just warn you that this is still uncertain, because there's other reasons why people might make friends, but we controlled for a number of them in these models. The other thing that was really good to find out in this study was the fact that immediate neighbors actually had no effect on one another. And so what this means is that it's not going to be the gym opening up in the neighborhood. It's not a context effect, because if that was true, then the neighbors should all be going up and down together, and that's not what we find. It also means that it's not these casual relationships that can cause this behavior to spread. It's only deep, close social relationships like your friends, your spouses, and your siblings that can have an impact on you. Which means that all of the media attention that this paper got that said, your friends make you fat, really kind of went overboard, because they gave this perception that you could sit next to someone on the bus and become obese. And that's not the way it works. The way it works is that we have deep, meaningful relationships with people, and we pay attention to them. And we make changes to their life when they make changes to their life. This isn't about strangers, it's about deep relationships. Now, after the obesity study, we actually went into a number of other health outcomes to see whether or not we'd find the same things. And over and over again, we find this result that the behaviors cluster to 3 degrees of separation, but no further. So for smoking, we find this. And smoking is an interesting example, because it's the exact reverse of the obesity epidemic, where we went from a high incidence, about 40% in 1971, down to a low incidence of about 10% in the early 2000s. And so maybe this is a model for how we can reverse the obesity epidemic. The problem is that one of the things that we found in this study was that the behavior actually had an impact on the shape of the network. So what do I mean by that? What I mean is that in 1971, it didn't matter whether you smoked or not. You could be someone who was very popular. You could be at the center of the network, or you could be on the periphery. It didn't matter. There was no relationship. But starting in the 1980s, we noticed a change. Smokers started getting pushed to the outside of their social networks. And this is an example here in this circle, a sort of blown up example. The smokers here are in yellow and the non-smokers are in green. And as a consequence, while we were improving the physical health of a number of people by helping them to quit smoking with these public health campaigns, we are actually hurting the social health of smokers and polarizing them so that they were only connected to other smokers. And it makes it much harder to reach them now if we think, as this study suggests, that these social networks are very important for spreading positive behavior change throughout the network. We also studied drinking behavior. And with drinking, we found another dilemma. One of the interesting things here is that we found that abstaining extends to 3 degrees of separation, that heavy drinking extends to 3 degrees of separation. But that one of the things that we found was somewhat counterintuitive. So it won't surprise you to learn that the people in the network who were most susceptible to drinking, to heavy drinking, were men. But when we looked to see whether or not men were influential, we couldn't find any effect. It was in fact the women who were driving all of the effect when we found that one person's drinking behavior was correlated with their friends' friends, and even their friends' friends. And so as a consequence now, we have a choice to make whenever we're doing an intervention. If this is true in other populations, do we treat the people who are susceptible, or do we treat the people who are influential? If you treat the men, you might be able to help them, but you're not going to get any multiplier effect. You're not going to get the she told two friends and she told two friends effect. If you treat the women, you might actually be able to reach a lot more men than you would have if you targeted them directly. And we would never have known this if we hadn't done this social network study. And it points to the importance of really thinking about how social networks shape the behaviors that we're interested in changing. Now, in addition to health behaviors, one of the things that Nicholas and I were really interested in is emotions, because emotions are part of the reasons why these behaviors get transmitted from one person to another. And so we also studied happiness. And here's another map from the Framingham Heart Study, where what I've done is I've colored all of the nodes who are happy, the people who are happy, I've colored them yellow, and I've colored all the people who are sad blue. Get it? Blue? Okay, so the idea here was to see whether or not we had the same kind of spread of behavior with affect that we had with these health behaviors. And that's exactly what we found. We found that these behaviors extend up to 3 degrees of separation. There's some evidence of an influence effect. And one of the interesting things that we find here is that the effect is temporary. And so this is consistent with what economists tell us about happiness. They've studied people who win the lottery. And not surprising, when you win the lottery, the next day you're a little bit happier. In fact, you're happier for about a year. But then after a year, you go back to being just as miserable as you were before. And this is what we found here. People who came in for their bi-yearly exam, within a year of one another, their behavior was correlated, their outcome on happiness was correlated. But if it was past a year, it wasn't correlated. And so these effects, they're temporary. We tend to adjust to our life circumstances. And people like Dan Ariely have really sort of driven this point home with their own research. Now, although it's the case that we think that we've done a good job of doing the best we can from these observational studies of trying to infer a causal relationship, it's true that it's just an association. Correlation is not causation. And so one of the things that we've started to do is some experimental studies. And one of these experimental studies had to do with generosity. So it turns out economists are very interested in this question of whether or not people contribute to group projects, whether or not they contribute to public goods. And the idea is that you would have people come into the laboratory and give them some money, and they could keep the money, or they could give it to a group project. If they gave it to the group project, then everybody else in their group benefited except for them. And so if you ask an economist, depending on whether or not they're an old school economist or a new economist, the old school economists would be stunned to find out that anybody gives anything. Because their models all assume that we're self-interested. They assume that we keep everything for ourselves. But in fact, time after time in these studies, we show that people are actually cooperative, that they will cooperate with one another, they'll be altruistic, that they'll give money to the group even when there's nothing in it for themselves. But there's variation. And so one of the things that we did is we actually exposed people to different groups. And so we had people play in a group of 4, and then go and play with a different group of 4, and go and play with a different group of 4. And we were able to draw a network from this, because our hypothesis was that when you play with the other 3 people, you see what they do, it's going to affect your behavior when you play with the new group. And then maybe they're affected by what you do, and that'll affect what they do when they play with their new groups. And that's exactly what we found. We found these generosity cascades that extend to 3 degrees of separation. What do I mean by that? I mean, if Eleni gave $1 more to the group when she was playing with Lucas, that means that Lucas in the next round would give 20 cents more to the group when he was playing with Erica. Erica would give 8 cents more in the next round when she was playing with Jay, and Jay would give 5 cents more in the next round when he was playing with Brecken. And in fact, when you add up all of the effects from a single extra dollar of giving, one of the things that we found in this experiment was that it actually yielded a total increase in giving of about $3. In other words, the network acts like a matching grant. And this really represents the power of the social network as a multiplier. Social networks tend to magnify whatever they're seeded with. And as a consequence, I think it's really important for us to try to understand the power of these networks in order to be able to change behavior. Now that I've talked to you about these real-world networks, you might ask yourself, okay, you talked about Facebook at the beginning. I want to hear something about Facebook. And these real networks, one of the reasons why it's so exciting now to think about how they work is that we have this potential to take this information online and see how they work there. Before I tell you what I think about online social networks, I want to introduce you to another expert on online social networks. Does anybody know who this is? This is Alyssa Milano. So she's a television actress. She was in the hit series Who's the Boss? And she also, for those of you who might be a little younger in the room, was in the series Charmed. She loves to tweet, and tweeters love her. In fact, she has over 1 million followers on Twitter. Now, given what I've told you so far in the lecture, you might think to yourself, that must mean she's really influential, that she's really powerful, that she has the potential to change lots of people's behavior. Maybe, maybe not, because remember, the neighbors were not affected by each other in the obesity study. So it's an open question whether or not these online relationships, which are much weaker, they're not strong relationships, so she doesn't have a close personal relationship with all these million people, what effect do they have on behavior? Well, we were able to actually do a little anecdotal experiment here because she actually tweeted a link to our book Connected about social networks. And she not only tweeted a link to the book, she tweeted a link to the Amazon webpage. So all her followers had to do was click on the link and go and buy her book, and I could quit my day job. So we went to the data to see what impact this would have on our book sales. And these are our book sales over about 30 days. And see if you can guess where she tweeted the book. She tweeted it right here. Okay, so you can see clearly sales did not go up the next day. In fact, they went down. And so what this demonstrates is that even though she has 1 million friends online, 1 million people who follow her on Twitter, that these 1 million people don't even add up to a single extra book sold. And it could be that her audience doesn't like books on social networks. There's lots of different reasons why this might not work. And this is not science. This is just an anecdote. But we've actually done some science to demonstrate the fact that it's the strong ties in these online networks, just like in real-world networks, that tend to be influential for behavior. And so to wrap our heads around this a little bit, just think about the difference in scale of the real-world relationships and the online relationships. This is a picture of a dorm that we had everyone give us their list for, of about 105 students. And you can look at the real-world friendships. You can imagine other kinds of relationships they might have with people. So they might be members of the same club. They might be roommates, and you'll notice the roommates aren't always friends. This is college, after all. Now let's think about what happens when we layer the Facebook friendships on there. What does it look like? Well, it looks like a big mess. It's a big ball of spaghetti. The average person on Facebook today has 150 friends. That's very different from the number that we got in the Gallup survey. It said on average people have about 5 close friends, people that they spend their free time with and people that they discuss important matters with. And so how do we use this online information? Well, one of the things that we have started to do is to try to think about which of these online relationships are a proxy for real-world relationships. And there is some information that we can use to that effect. So for example, consider this network. This is the same network that you just saw, but now what I've done is I've only put lines between people who have a specific kind of relationship, and that is people who have tagged one another in photos on Facebook. So tagging on Facebook works just the same way as turning a real-world photo over and writing Aunt Sue, right? So you know Aunt Sue. You're probably there at the same time as her because you own the picture. You took the time to write it. All the same rules apply on Facebook, and we expect that people who engage in this tagging behavior online, on average, are going to be much more likely to have this real-world relationship than the other people that they didn't tag. And when we do this, we start to get correlation in behavior We didn't have any correlation in behavior when we just looked at all the Facebook friends, but here we do. And to demonstrate, in this map, what I've done is I've colored all the nodes yellow for people who are smiling in their profile pictures, and blue for all the people who are not smiling. And that's Nicholas, by the way. I always have to make fun of him. And these clusters, they extend to 2 degrees of separation. We've also done this research for less non-trivial things, and we've actually taken a bunch of undergraduates to code people's body mass index from their Facebook photos. We have high intercoder reliability, so it's not getting on a scale, but it's not bad. And what we find here, whenever we look at this network, is that there are clusters of overweight men and clusters of overweight women that extend to 2 degrees of separation. And so this is starting to look like what took us some felicity and hard work in the Framingham Heart Study to do. Now we have all this massive passive data that's collected online that we might be able to do these massive studies of the whole population in order to be able to study how this works and maybe, just maybe, to start to do interventions. So what kind of interventions could we do? Well, there's 2 different classes of interventions. One is you can change the connections. The other is that you can affect contagion. Okay, so think about your list. How much money would I have to pay you to get rid of one of your friends? I'd probably have to give you a lot of money. In fact, it probably doesn't even make sense to you to think about things that way. There are things that we do that we don't do for money. If you pay someone to give blood, they actually give less of it. The same thing happens with friendships. Friendships, we don't categorize them in that way. It's very hard to manipulate these relationships. We can do it in certain limited circumstances, like when we randomize people to be roommates with one another in college or bunkmates in the Army. But other than those moments, it's very hard to manipulate people's social networks. Just ask anyone from Weight Watchers or from Alcoholics Anonymous. They know this is important. They try to get people to do these behavior changes with their friends and with new people that are going to be positive, but sometimes it's very hard to maintain those new relationships. Contagion, on the other hand, might potentially be quite easy to manipulate, because here all we have to really do is we have to think about, well, who do we target? Who do we send an intervention to if we have limited resources? If I can't try to get 100 million people all at once to do something in the United States, I don't have money to get 1,000 of them to do it. Which 1,000 of those people do I target? So I want to talk to you a little bit about a couple of projects that we have done that are related to each one of these 2 ways of intervening in networks. The first one has to do with connection. And here we're very interested in the way doctors are connected to one another. And so this is the physician network in Boston area hospitals, where each circle is a doctor, and each line is a relationship that is defined by 2 doctors that share 10 or more patients in common. Now, this doesn't mean that those doctors know one another, but they certainly are exchanging information because they see each other's charts as they're treating the same patients. And one of the things that you'll notice is that some of the hospitals are very isolated, where all the doctors are pretty much just sharing patients with other doctors within the same hospital. But other hospitals at the center of the network, they're actually quite diffuse. They share patients with lots of different hospitals, and they probably play a really critical role in sharing information across this whole hospital system in this major metropolitan city. But the other thing that we can do is not just look at Boston. We can actually look at these hospitals all over the country and start to think about, well, what kinds of structures would have impacts on hospital costs? And so one of the things we did is we started making maps like this. This is a map of the doctor network within one hospital in upstate New York, an unnamed anonymous hospital. And what we did is we mapped this network according to whether or not the doctors were in primary care or they were specialists. And one of the things that you'll notice is the red nodes here, the primary care doctors, they're not very central. It's the yellow nodes and the green nodes, the specialists, that tend to be at the center of this network. Now compare that to another hospital in upstate New York. On the right here, it's exactly the same number of patients, exactly the same number of doctors. So it's about the same size hospital, same size network. And here, you have the primary care physicians rather than the specialists who are at the center of this network. Now, guess which one of these 2 hospitals has lower costs? The one with the specialist at the center of the network, or the one with the generalist at the center of the network? The one on the left is the one with the specialist has, higher costs. In the last 2 years of life in this particular hospital, they spend about $104,000 per patient, and they have about 48 days of inpatient care. Compared to the one where the generalists are at the center of the network, they have about $46,000 in the last 2 years in costs and 25 days of inpatient care. And so one of the things that this suggests is that maybe these hospitals where specialists are at the center of the network, they make decisions about the hospital that orient the hospital towards, for example, getting more specialty tests done, because we all tend to be a little bit self-interested. And maybe it would be the case that in an intervention, what we might be able to do is change the way these doctors interact with one another, change the patients they share, change the social activities that they engage in the hospital in order to try to create more space for the generals to be at the center of these networks in order to lower costs. So this is something we're going to be looking at next. This is just an association. We find it for hundreds of hospitals throughout the United States. And it's possible that other things drive the association. Like it could be that some hospitals just have a reputation for being a specialty hospital, which could drive both the style of the network and the costs. But it's very suggestive of the fact that this is an opportunity for us to think about how we might structure the connections in the network in order to try to achieve a good outcome. Now, another project that we've been working on is on contagion. And before I talk to you about this project, let me just sort of ask you a question. Suppose that you lived in this network and you were one of these people. You could choose anyone that you wanted to be. And before you choose, I'm going to tell you a real important fact. There's a deadly virus spreading through this network. Do you want to be at the center of this network, or do you want to be at the periphery, on the edge? Right, you want to be on the periphery. You want to be the hermit that avoids the Black Plague, right? Now, if a juicy piece of gossip is spreading through the network, do you want to be at the center or at the periphery? Well, it depends on if you want to know. If it's about you, maybe you don't want to know. But if that's the case, if you want to be able to catch these good things that are spreading through the network, you might want to be at the center. And so one of the things that's really important to understand about the way these networks work is that people at the center of the network, they tend to be more susceptible and they tend to get things sooner than other people in the network. And so the reason for that is that people at the center, there are a smaller number of steps from other people in the network. So it only takes 2 steps on average, for example, to get to someone at the center of this network, whereas if you're on the edge, it might take 3 or 4 or 5 for whatever is spreading through the network to get to you. Eventually, it might get to you anyway, but it's going to take a longer period of time. So ideally, what you'd like to be able to do is use people at the center of this network to be able to monitor the network. Because if they get things sooner, you're going to know things about the population sooner if you know what's going on with them. But here's the problem. I already told you it's really hard to collect social network information. And I asked you guys all to name your lists, but normally what we have is we have information like this. We have a bunch of Robinson Crusoes in this population, and we have no idea how they're connected to one another. At best, what we can do is we can go and talk to 6 randomly chosen people, and then find out from them, oh, have you gotten the deadly virus? Have you gotten the deadly virus? And aggregate that information to know something about what's going on to the population. So ideally what we want to do is we want to figure out some way that we can monitor the network without having all that network information. So one idea that we had was that rather than talking to these 6 randomly chosen people in the network, what we would do is we'd talk to one of their friends. So in other words, I would ask everyone in this room, give me your list. Okay, good, you're done. You're out of the study. Now I'm going to go talk to your friends, and your friends will actually be the ones in the study. And the reason why this works is because of another very sad fact about your lists. Did you know that your friends have more friends than you do? So think about that for just a second. Even if you're a very popular person, chances are very good your friends have more friends than you do. And the reason for this is that if you have 10 friends, you're 10 times more likely to be named as a friend than if you have only 1. And so the people that you name, by virtue of this selection, they tend to be people with more friendships. It's a mathematical effect. And you can see this person on the periphery, when we put the network information back, that person only has one choice. They can only name one person. That one person, by definition, is closer to the center of the network. And this same principle operates for all these other individuals. The people that you name, they tend to be more central. And so we want to follow those people and see what happens. And what we're going to do is we're going to follow them through a contagion. And just to remind you, a contagion, the way that works is that if a deadly pathogen is flowing through a network, or any kind of pathogen, what tends to happen is a few people will be infected at first, but then she tells 2 friends, and she tells 2 friends, and so on, and so on, and so on. And eventually you have this exponential growth. And then eventually what happens is that you run out of people to infect, and as you're running out of people to infect, that tends to be the backward curve of the S. This is a very classic curve. And what we would expect if we were following these friends in the network, rather than just following the population as a whole, is that that whole curve is going to be shifted forward in time, because there are a shorter number of steps from everybody else in the network. And so to test this, we actually followed an H1N1 epidemic. at Harvard College in 2009, and we tracked flu-like illness by diagnosis by physicians, but also by self-diagnosis. We pinged them by email twice weekly. We had them name friends, so we actually got a good map of their network, and we followed the friends to see what would happen to them. This is a video, actually, of the epidemic as it's unfolding. And the red nodes are the ones that are infected. The yellow nodes are the ones that are susceptible. They're the ones that are exposed to someone with flu-like illness. And you'll see kind of here that the people in the center are getting the flu earlier than other people in the network. And it's a little hard to see in the video, but whenever you look at the cumulative incidence curve that shows you something like those S-shaped curves before, of course, data is messy, so it never looks exactly the same, but it's shifted forward. You can see that yellow line, that's the friends, and the red line, that's the population as a whole. And in fact, what we were able to show is that this curve was shifted forward by about 2 weeks. So in other words, if we wanted to know what was happening to this population, if we'd just been randomly asking people, do you have the flu, we wouldn't have done nearly as well as we would have had with our friend method, which would have given us 2 weeks advance warning of any threshold level of contamination in the network that we would want to be able to monitor. In fact, at a very early point in the course of the epidemic, those two curves shifted for one another, and we suggested this is another way that you might be able to use this as an early detection device, because there's some things that sort of have a constant rate in the population, and you want to know when they're diverging, because when they diverge, it tells you that something is going on that's causing it to spread. So anything that really spreads via a social network process, you could monitor in this way. And if you had if you had access to the network information, so say Facebook made its data available for people to track this, and we could look at all the photo friends or use other methods to try to infer the real-world friendships. We could also use measures like measures of centrality and other network measures to be able to get early warning as well, but it's not strictly necessary. This friend method worked quite well. And this can be applied to pathogens, obviously, but it can also be applied to information. You might want to know whether or not doctors, for example, are getting the latest information about side effects of drugs that they prescribe. It's very important that they get this soon, and so you might want to monitor this. You also might want to be able to manipulate this, so you might want to get the doctors who are most central to be the ones who get the information first. You want to see whether norms are changing in the network. There's some evidence. Dan Hrushka has a paper, for example, now that suggests that the obesity correlations that we found, that about 30% of the variance in those correlations can be explained by nothing more than changing norms or changing ideas about what appropriate health behavior and appropriate body size are. And so it might be important for you to get early warning of those norms moving through the network and trying to figure out who do you ping in order to be able to change those norms. And of course, you have behaviors that are a consequence of some of these norms. So eating behaviors, exercise behaviors, vaccination behaviors, these are all things that you ideally would want to be able to monitor with some advance warning. And it's really critical to understand that what this study really shows is that if we can really get so much advance warning from this select group of individuals, it means that if we act on those individuals, if we intervene on those individuals, then we may be able to get really large multiplier effects in terms of reducing the overall incidence of something that's spreading through the network that we don't want to spread in the network. So let me just conclude the talk by observing that it's obvious, it must be obvious to you at this point, that I'm just enthralled with social networks, that I think that this is a really interesting area of study, but I also have this personal mission that relates to my experience as a social network researcher. This is a scene from the movie Pay It Forward, where a small boy is explaining this crazy idea he has to all of his classmates. And it goes like this: I'm going to make the world a better place by doing the following. I'm going to do 3 random acts of kindness to 3 people, and I'm going to ask them to do nothing in return for me. I'm going to ask them to pay it forward and do 3 random acts of kindness to 3 other individuals. And you see, he looks like a budding network theorist here. He's got the nodes and the lines, and he's realized the she told 2 friends effect is what makes this powerful, that 3 can turn into 9, can turn into 27. So this is not only true for public health, it's true for our personal lives. I think it's really important that each of us recognize that we have network power. And what this means is it's not just the case that we're influenced by all these other people in the network. That's true, but that's not the way to react to this information. We don't just say to ourselves, oh, when my friend's friend gets fat, then I'm done for. I think a different way to think about this is that we are far more powerful than we previously realized. We affect not only our own outcomes, but we also affect the outcomes of hundreds of people that we can't see and people that we potentially have never even met. And this has had a profound impact on my own life. I actually lost 5 pounds after the obesity study, and I kept it off because I realized that I was not only making myself healthier by doing that, I was potentially also making my son healthier, and my son's best friend, and maybe even my son's best friend's mother. These effects spread through networks, and when we realize that we have network power, I feel convinced that one of the things that will result is that we'll take more responsibility for our actions. When someone tells you you don't influence anyone, you probably don't try as hard as you do when someone says a lot of people are depending on you. And those people are not just random people. They're the loved ones of your loved ones, and the loved ones of your loved ones' loved ones. These effects spread through networks, and it makes me convinced that one of the things that we really have to do, not only to understand how health works and then make the world a healthier place, is to understand more about our own role in these social networks, because the fundamental thing that really makes human beings unique, I think, is that we are all connected. Thank you very much. Yeah, so one of the questions is what happens to networks as people age? So one of the interesting things about Framingham is that by the end of the study, the average age is some people in their 60s, because they've been even the children of the original group are all already quite advanced in age. And so we're able to actually see what happens. And we include age in all our models as a control because it has a pretty profound effect. I can't remember what the numbers are, but we do see a relatively steep decline in the number of social connections for people in their 60s or their 70s and their 80s. Some of this is the result of their friends passing away, but some of it also probably has to do with the social isolation that comes with, for example, caring for an elderly or a sick spouse. And this, I think, can probably have a big consequence for all kinds of health outcomes for people of advanced age. So I think this is a really important question. One of the things that that I didn't talk about today, we've done research with John Cacioppo on loneliness. Loneliness is another ill that affects the elderly at a greater rate. And one of the things that we found in our study with him was that there's a relationship between how lonely you feel and how isolated you are in the network. So in other words, if your list is smaller, then I can predict that you'll actually be more lonely, which makes perfect sense that those two things would be related. But when you look at how those two things interact with one another, there's this terrible reinforcement effect where if you feel lonely, you actually tend to disconnect to people in the future. And if you're disconnected from people, you tend to feel lonely in the future. And so you get this image of this network that's sort of, you have some lonely elderly people at the edges, and it's becoming unraveled like a sweater when you tug on a yarn. And to us, what it really indicates is that whenever you are doing things to try to help bring those individuals back into the social fabric of society, you're not just protecting them, you're really protecting everyone from those consequences. Sure, okay, so the first question is about Facebook. And a couple of observations. One is you had this stranger who sent you a letter thanking you for your daughter, but you're also very afraid of the privacy implications. And then the second question is, what is this graph that I have up here right now? I'll answer the second one first because it's easy. That's the network of all the people that we were friends with when we were writing the book. So that's our social network. That's Nicholas Christakis' and my social network. And in our book, we actually put this diagram as a thank you to everyone who helped us as an acknowledgement. It was actually very hard to put together because there's a lot of people there, and I had to know whether or not each one of those people is friends with each one of those other people, and there's about 100 people there. And so that ends up being about 10,000 connections that you have to decide, who is on whose list. So it's very complicated, but that's what that diagram is. On Facebook, you're right. We have over 700 million people on Facebook today, and it's probably going to be 1 billion sometime within the next year. This is huge. It's a huge change in our society. I find it really interesting the way you described the problem, because you talk about this really beautiful thing that happened to you as a consequence of Facebook, but on the other hand, you're very worried about privacy. And I think a lot of people have this love-hate relationship with it. And honestly, the reason why I think we have a love-hate relationship with it is because we have a love-hate relationship with real-world social networks. Right, so we thrive on social activity. Like we're all here today. We're spending time with one another today. We're meeting new people. We're with other people. We are a social species. But we also feel great stress about people comparing status to one another. And one of the very first reactions my wife had to Facebook was that she felt left out. When she first joined Facebook, she saw all her friends doing these things that she never knew about before, and she felt social pain because she felt like she wasn't keeping up, like she wasn't able to participate in all these things, and they weren't inviting her, and so on. And so it's what's new about this, in recent history anyway, is that we are able to see all of these relationships and have information about these friends of friends and these friends of friends of friends that we didn't previously have. I think, though, that our brains are actually built for this world because we did not evolve in cities. We evolved in villages. We evolved in villages of about 150 people, if you talk to Robin Dunbar. And the interesting thing about a village of 150 people is that if it's the case that you have about 5 friends on average, that means you have about 25 friends of friends. You have about 125 friends of friends of friends. In a village, the relationships, they only go out to 3 degrees of separation. And so I think that part of the anxiety that we're feeling is not that this is taking us away from something that's natural. It's taking us away from what we're used to. But in fact, I think it's something that is more natural than what we've been experiencing. You know, cities have created anonymity and privacy like we never had. You know, the biggest worry on Facebook for college kids is drunk photos. Do you think that if you got drunk in the village 10,000 years ago, that there'd be anybody in the village who didn't know about it? And so I really think that one of the things that we're seeing on Facebook today, this struggle with privacy, it has to do with this shift from the anonymity that we developed and experienced in cities back to a state of life where we're going to be in our own villages that we stay in touch with online to overcome like the increased mobility and the increased distance that we have between the people that we're close to. You know, you go back even a couple hundred years, it would have been unusual to be close friends with someone who was 100 miles away. But today, it's very typical for you to maintain close relationships with people even that live very far away. I actually work directly with Facebook now, and I can tell you they care a lot about privacy. It's been pretty remarkable. There's been research that I wanted to do, that I have permission to do from the Human Subjects Board here at the University of California, San Diego, and Facebook said, no, we're not going to let you do that research. And so they're very conscious of the fact that they have tremendous power. And they're trying to figure out what to do about it. They're trying to develop systems that will make people feel more comfortable and to really to be able to feel private with the sharing of their information. When I go to Facebook, one of the very first things that Elliot Schrag will always say to me when I'm saying, well, you know, isn't Facebook doing this and isn't that a bad thing? He'll say, well, okay, I always compare Facebook to the telephone. All right, so try to think about if you say Facebook does something, you know, what does the telephone do? Well, if you think about what happened with the telephone, people also were really upset about their privacy being invaded. So it's not surprising that we're having this conversation now. In fact, men were terrified that their women would be stolen by dandies who would call them while they were at work and you know, woo their wives to leave them. And this was something that was literally in the press at the time. You know, this concern about strangers being able to reach into the household. And so my sense is that we're going to go through a generational change where young people are very, very used to living in this environment of this shared privacy. And the reason why they got used to it so quickly is they didn't develop the same kind of cultural norms that older people developed living in cities and living in this very anonymous Robinson Crusoe kind of life. That's just one person's opinion. I'm sure I've already evoked lots of disagreeing ideas in people in the room and other experts, but I have this optimism that these problems are going to be worked out and that we're going to be able to adequately control the power that any organization, whether it's Facebook or Google Plus or whatever comes in the future, might have over our social data.